Welcome to the DIY Honda Garage channel. This presentation will cover the Diagnostic Trouble Code DTC P0103, which indicates a high voltage reading from the mass airflow MAF sensor circuit in the Honda CR-V models from 2011 to 2016. The MAF sensor plays a crucial role in the vehicle's engine management system by measuring the volume of air entering the engine. A high voltage signal could lead to incorrect air-fuel mixture readings, potentially affecting engine performance and emissions. Therefore, it's vital to understand the symptoms, possible causes, and steps needed for effective diagnosis and repair when this DTC is present. Let's dive into a detailed error description. DTC P0103 is specifically related to the mass airflow MAF sensor circuit in the Honda CR-V. The MAF sensor is typically located in the air intake path, right after the air filter and before the throttle body. Its primary function is to measure the amount of air entering the engine, which helps the powertrain control module, PCM, determine the proper air-fuel mixture for optimal engine performance. A sustained high voltage above the threshold of 4.89 volts indicates a potential issue leading to this DTC. The PCM, located in the passenger compartment, processes the MAF signal to adjust fuel delivery accordingly. Wiring connecting these components must also be inspected as they can contribute to malfunctions. Several factors may contribute to DTC P0103 being triggered. A faulty MAF sensor can provide erroneous readings, resulting in high voltage signals. Additionally, poor electrical connections or loose terminals at the MAF sensor, intake air temperature, IAT sensor, or the PCM can lead to inconsistent signals. The PCM software may also require an update, as outdated software can misinterpret sensor signals. Lastly, an open circuit in the wiring connecting the MAF sensor to the PCM can cause high voltage readings. Each of these components and conditions needs thorough checking during diagnostics. When DTC P0103 is triggered, there were several observable symptoms that drivers might experience. One of the most common indicators is an illuminated check engine light, which alerts the driver to potential engine issues. Drivers may also notice poor acceleration due to the incorrect air-fuel mixture being delivered to the engine. Increased fuel consumption is another likely outcome, as a high voltage reading can lead to an overly rich mixture. Lastly, in severe cases, the engine may stall, posing safety risks. Understanding these symptoms can aid in quicker diagnosis. In the first troubleshooting step for DTC P0103, start by turning the ignition switch to on 2 and wait for 2 seconds. This action initializes the vehicle's electrical systems. The next step involves checking the parameter values with the Honda Diagnostic System, HDS. You will specifically be looking for the MAF sensor's voltage. It should not exceed 4.89 volts during normal operation. If the current conditions match this threshold, the failure is confirmed, and you will proceed to the next step in the diagnosis. If not, it may indicate an intermittent failure or a transient issue. In this step, you will focus on checking the wiring integrity associated with the MAF sensor circuit. Start by turning the ignition switch to lock 0, and then jump the SCS line using the HDS tool. After this, disconnect the 5P connector from the MAF sensor IAT sensor and the PCM connector B, 49P. The goal now is to check for continuity between specific test points. PCM connector B, pin 43, light green, and MAF sensor IAT sensor 5P, pin 4, light green. If you find continuity, It indicates that the wiring between the PCM and the MAF IAT sensor is intact, permitting you to move forward to the next diagnostic stage. In the final troubleshooting step, first, reconnect the PCM connector B to restore connection. Then, use a jumper wire to connect terminals A and B on the MAF sensor IAT sensor 5P connector. Once you have set up the jumper, turn the ignition switch to on, 2, once again. This temporary connection will allow you to isolate the issue to the PCM. Next, clear any stored DTCs using the HDS tool. After clearing them, check for any pending or confirmed DTCs. If DTC P0103 reappears, you may need to update the PCM software if it is outdated. Alternatively, consider substituting with a known good PCM to further diagnose the issue. Upon completing repairs related to DTC P0103, verification is essential to ensure the issue has been resolved. Start by turning the ignition switch to lock 0 to safely reconnect all previously disconnected connectors. Next, turn the ignition switch to on 2 and reset the PCM using the HDS tool. It is crucial to perform the PCM idle learn procedure afterward, as this helps the engine management system relearn idle parameters. Finally, check again for any pending or confirmed DTCs using the HDS. If DTC P0103 is still present, revisit earlier steps to identify any potential missed issues. If the DTC is cleared and everything checks out, then the repair is complete. To avoid encountering DTC P0103 in the future, several preventive maintenance measures can be undertaken. First, regularly inspecting all electrical connections related to the MAF sensor and PCM can help mitigate potential issues. Dust, corrosion, or loose connections can lead to intermittent failures. Additionally, cleaning the MAF sensor periodically is beneficial, as dirt or debris buildup can affect its accuracy and responsiveness. Finally, keeping the PCM software updated will ensure that the vehicle's diagnostic systems remain efficient and effective. Adopting these proactive steps can significantly reduce the risk of further DTC occurrences and improve overall vehicle performance. In addressing DTC P0103, understanding the critical role of the MAF sensor and its interaction with the PCM is crucial for effective diagnosis and repair. By thoroughly following the outlined troubleshooting steps, technicians can pinpoint whether the issue lies within the sensor itself, the wiring, or the PCM. Regular preventive maintenance, including inspections and cleaning, is essential in maintaining sensor reliability and preventing future DTC occurrences. Remember to perform all verification steps post-repair to confirm the integrity of the system. By adhering to these principles, you can ensure optimal performance and operation of the Honda CR-V. Please like and subscribe to the channel. See you next time.